In this video, we discuss the three types of navigations that Genexus implements when it finds nested for each commands. We'll come back to them to formalize them a bit more. When we're inside the body of a for each command and there's another one, it means that for each record in one navigation of a table, we want to run through many records in another navigation of the same or another table. A particular case is when a single record is retrieved. First, the base tables are determined, and then the relationship between them is explored. This will lead to one of three cases: join, Cartesian product, and control break. We're aware of a first major difference. The first two cases will involve different base tables, while the latter is a case of the same base table. What's the difference between a join and a Cartesian product? The identification of a direct or indirect one-to-n relationship. Let's formalize all cases. Let's suppose that we have these 5 transactions to record the tourist attractions that can be visited on tours, where each attraction corresponds to a category, such as museum or monument, and is from a city in a country. On the other hand, we have hotels in each country and city. From these transactions, we obtain these tables with their relationships. Let's start with join. How will this code be resolved? For each country name, you need to print the attraction names with their visit time specified in the trip. Is there a relationship between the information? We know that a trip attraction record belongs to a single attraction, which corresponds to a single city, which in turn corresponds to a single country. In other words, from the trip attraction table, we reach country in a unique way. Therefore, for the second for each, we can print only the trip attractions corresponding to the country of the main for each, as we can see in the navigation list as a constraint. This country ID, preceded by the @ sign, corresponds to the country ID of the record of the external for each where we're positioned, and this country ID attribute is that of attraction, which is reached through trip attraction. Clearly, this is a join with a 1-to-n indirect relationship. This is because for a trip attraction following the foreign keys, we find a single country ID. Therefore, for a country ID, we can find n trip attractions that will find it by following this path. If we formalize this case of 1-to-n indirect relationship, we're saying that the base table of the main for each is contained in the extended table of the nested for each. That case includes the simplest of all. For example, consider that if the base table of the second for each were country city, this formula would be satisfied. Here we see more clearly the relationships between the tables involved in this case. That is, the base table of the main one is this one, and the base table of the nested one is this other one. The indirect 1-to-n relationship is clear. It's indirect through the extended table of the nested for each. Now let's look at the other type of indirect 1-to-n relationship, this time through the main one instead of through the extended table of the nested one. For each trip attraction, we print the attraction name and visit time on that trip, and then the hotel names. Here, it's clearly not true that the base table of the main for each is included in the extended table of the nested for each. There is no indirect 1-to-n relationship through this way. However, we know that for each record of the main for each, we reach a record of this table, which is also reached directly from the base table of the nested one. That is to say, in this one, there will be a foreign key to this other one. They'll share this attribute. Because of it, this 1 to n relationship is established between the tables. In short, the extended table of the main for each will have some attribute in common with the base table of the nested one, and they will establish the join. Here they'll be country ID, city ID, foreign key to country city. We can see it clearly in the navigation list. Only the hotels corresponding to the same city of the trip attraction will be printed. Again, to see it more clearly, let's keep only the tables involved. Here we see the indirect 1 to n relationship. If in the first case, this base table was run through, and for the nested one, this other one, and therefore the relationship was indirect 1 to n through the extended table of the nested one, in the second case, it's through the extended table of the base table of the main one. And it's here that the 1 to n relationship is established with the base table of the nested one. Therefore, the join case is that of different base tables where a direct or indirect 1 to n relationship is found, according to these options: base table with extended table, or extended table with base table. There is no extended table with extended table. That is to say, if the base table of the nested one is not this one, but this other one, there is a relationship between the extended tables, obviously, because both arrive at the same table. However, here there will not be a join, but a Cartesian product. Why? If for each record of the base table of the main for each, we may keep only those of the base table of the nested one that correspond to the same record of this table to which both arrive in a unique way. The more indirect the relationship, the less likely it seems that the developer is looking to take it into account, because the relationship seems more and more distant, and if the developer is looking for it, they can always make it explicit. For example, by assigning to a variable the value of the attribute that's obtained by following the path of the extended table of the main for each, that is to say, the value of this attribute that matches this one. And in the nested for each, explicitly filtering the records from which you get to this other attribute that's called the same because it's also a foreign key to the common table. Let's take this opportunity to make a clarification. When we speak of a join or Cartesian product, of this difference, we're referring to the implicit determinations of Genexus, not to whether it ends up filtering the information of the nested one. Note that in this case, it's a Cartesian product in the sense that if we had not written a where, Genexus would not add it implicitly either. And all the records of the nested one would be returned. Actually, in this case, not all the records in the nested one will be returned because we explicitly wrote a where, so it will actually do a join, but not the implicit join of Genexus. The more distant the relationship, the less likely it will be that the developer has it in mind, or is trying to enforce it implicitly. The following is an interesting aspect of this case. We add one more table to make it even clearer. If we do the intersection of both extended tables, we're left with the tables in common. Now, if in the main for each, we place attributes from these two tables, clearly, the values that will be taken will be those obtained from each record of the base table that meets the filters. That is to say, they'll be the ones coming from this extended table. But what happens if these attributes are in the nested for each? Are the ones from the extended table of this for each taken? If by one way or the other, we arrived at the same record in this table, it wouldn't matter at all, because they would give the same value by either way. That's what would happen if the join was done. But there is no join in this case. Therefore, the values of these attributes obtained in this way will not always be the same as those obtained in this other way. So which path will be chosen if in the nested for each attributes are placed from here or here? It will be that of the main for each. In fact, if we don't place a base transaction for the nested for each and we let Genexus calculate it, it'll first remove all the attributes of the nested for each that belong to the extended table of the main one. And, with those that are left, with those alone, it'll determine the base table. That is to say, it'll remove them, because it assumes that they are reached through the main for each. For example, if we add a conference room table with an n-to-1 relationship with hotel, and specify these nested for each commands, where these are clearly the base tables, we see that in the first for each, nothing is requested from the tables in common. In addition, from the base table, it would only be necessary to access attraction to obtain attraction name. But if we look at the nested for each, besides an attribute of hotel, country name of country, and city name of country city are displayed. We might think that it's then going to use the associated ones through conference room. However, if we look at the navigation list, we see that it doesn't. In the nested for each, it only accesses conference room to obtain the conference room name, and the hotel ID, through which it accesses this record in hotel to retrieve hotel name. And there it stays. Note that there's no join. So where does it retrieve the values of city name and country name from? From the main for each. Let's see that it accesses attraction to retrieve attraction name, but also country ID and city ID to be able to access these two tables and retrieve country name and city name respectively. And what would we do if we wanted the values of the country and city of the hotel of the conference room? An initial idea could be through a subtype. For example, if we define this group of subtypes and use it in hotel instead of the supertypes, we see that now the table has the subtypes, and it will be enough to replace the supertypes with the corresponding subtypes in the nested for each. Here's the navigation list with the information we were looking for. However, it doesn't seem like a good idea to place a subtype just because we want to remove the ambiguity in a case of nested for each commands. Note that here there's no ambiguity in the model. It would be different if this table existed to introduce two paths to get to these other ones. The smartest way to solve this problem, then, is to leave the model unchanged and write the second for each in a subroutine. Now the navigation list shows exactly what we want. Here, we're accessing country name and city name from conference room and not from trip attraction. Before moving on, let's focus again on the second join case that we had seen to examine for a moment what happens if the relationship exists through subtypes. Actually, let's look at the simplest example of all. What will happen if this relation is not created using supertypes, but subtypes? In the example we saw, if instead of country ID and city ID in hotel, we place these subtypes, if our nested for each commands are written like this, that is, first the attraction table is run through, and for each one, the hotel table is run through, then Genexus finds the relationship and performs the join. We see that in the first for each, it retrieves the values of country ID and city ID, and then in the nested for each, it filters the hotel records for which the subtypes match these. However, if the for each commands are written in reverse order, that is, in the external one, the hotels are run through, and in the nested one, the attractions are run through, a join will not be made, but a Cartesian product. The rule is, a join is made between supertype and subtype, but not the other way around. That is to say, since in hotel we don't have country ID and city ID, but subtypes of these particular cases, It's not clear for Genexus that the developer wants to go from the particular to the general and then only list the attractions with the same values for the supertypes. Here, it's summarized. Finally, going back to the case without subtypes, before moving on to the case of the same base table, let's add that both in the case of a join and of a Cartesian product, it's possible to use in the nested for each attributes of the extended table of the main one that are not in the extended table of the nested one. In the two cases shown in the nested for each, a request is made to print category name, which is not in the extended table of its for each, but it is in the extended one of the parent for each. Therefore, for each trip attraction, the values of these two attributes are printed, and the value of category name is obtained, which will be used in the nested for each as the given value. In the case of the join, the values of country ID and city ID are also obtained precisely to make the join. Then, in the first case, all the hotels of the same country and city are run through. There the retrieved values of country ID and city ID are used. And for each one, the name of the hotel and the name of the category obtained in the first for each are printed. In the second case, all the conference rooms are run through, without filters because there is no join, and their name, the name of their hotel, and the value of category name from the parent for each attraction are printed. Remember that to determine the base table of the nested for each, as well as to solve the navigation, the attributes that are in the nested one are already part of the extended one of the main one are removed first. It's for this reason. Now, let's examine the control break. We know that it takes place when the base table of every for each command is the same, and it only makes sense when we want to process grouped information. It can be grouped by any attribute or set of attributes of the extended table. For example, we group according to the value of an attribute of this table, which should appear in the order clause, and we process all the associated records of this table and the extended table that have the same value for that attribute. So, for example, we group the trip attractions by category, list for each group the category name, and scroll through the trip attractions of that category, printing the attraction name, visit time, and city name of the attraction for each of the trip attractions with the same category. So far, we didn't worry about the determination of the base table of every for each command because we took it for granted when using the base transaction. But when we leave this task to Genexus, what was a join can become a control break. We'll see this by returning to the last join case that we had analyzed. There is a slight difference. In the nested for each we're printing, instead of the names of the hotels with the same city of the trip attraction, the names of the city of each one of those hotels. Note that if we had specified country.city as the base transaction instead of hotel, then this would be the base table of the nested one. And it would be a particular case where the second for each would only return one record. We see it clearly in the navigation list that indicates for first instead of for each. Because, of course, country ID, city ID are the primary keys of the table. It's as if the for each had not been specified and the print block had been printed directly, because city name is in the extended table of trip attraction. That's why, if we don't set this base transaction, and we let Genexus determine the base table by itself, it'll choose trip attraction. That is to say, it'll understand that we want to implement a control break because assuming that the developer doesn't write unnecessary for each commands, nothing else will make sense. The navigation list will look like this. However, this will not make any sense either, because it'll be a control break by the primary key. That is, it'll work in the nested for each with the same record of the main for each every time. It would still be necessary to specify an order clause to break by some attribute or set of attributes whose values can be repeated. For example, category name. And so we have the same example of control break that we saw before. In summary, if the base tables are different, Genexus will look for a 1-to-n relationship of one of those two types. If it finds it, it'll implement an implicit join. Otherwise, it will not implement any join. And we call this case a Cartesian product. However, note that calling it a Cartesian product doesn't mean that it is actually one. If the developer explicitly adds a filter, it'll clearly bring the filtered records. So, there will be a sort of join, but it will not be the automatic join. We say the case is a Cartesian product only from the point of view of the automatic filters that Genexus determines. That is to say, in this case, there's none. The control break is clear. This is the end of the formal analysis of the three types of possible navigations when there are nested for each commands.